In this video, we will see operators in C language. These operators allow us to manipulate data. So let's find out about their different types and some rules whenever you are applying any of them to data. Let's first start with arithmetic operators. We already know most of them, like addition, symbol, subtraction, that can be also a negative sign, multiplication, division. This one is remainder or modulus. Whenever, remember, you have an uneven division, that is the one in which the dividend is not a exact multiple of the divisor. So for instance, let's say 10 divided by 4. We will have the next result 2, and we will have a remainder of 2. Why is that? Because we are not taking fractional parts. So that's what happens here. We do the division, and this remainder operator will find the remainder of that operation. Obviously, it had to be not taking fractional parts, but actually whole numbers. The next one is the increment, which will increment the numeric value of your data by 1 unit, and decrement operator, which will decrement the numeric value of your data by one unit. Now let's have a look at the different operators. Let's create two integer data types with numeric values. A equals to 10, B equals 45. And let's use the printf function to print the results. We're going to print a numeric value, which is the result. So let's say, for instance, A plus B equals B. Here we are. 45 plus 10, we will have 55. Now let's do subtraction. In this order, this will give us a negative number. And what's next? Multiplication. Okay, let's see the result. Okay, then division. Now remember that A is has a lower value than B, so we're going to have a result of 0 in the non-fractional part, because the result is going to be a decimal number with fractional part. However, if we proceed in the opposite direction, that is dividing the B value, which is higher, by A, we will have a different result, the result of 4. However, it is not the exact even division, but it will ignore the fractional part. However, if we use this remainder operation, the operation that can be just used in two integer data types, will show us the remainder. The remainder is 5, because remember, 10 fits 4 times in 45, but it will give us a total amount of 40, so 5 units will be left as the remainder of this operation. Okay, now let's review the increment and decrement operators. Bear in mind that these operators can be either prefixed or postfixed. What does that mean? When you use prefix increment or decrement operator, the operation of incrementing or decrementing will be executed prior. So this value A means that if you had a previous value of A equals 3, this plus A means that it is incremented prior to be used, so it is automatically converted to 4, yeah, incremented by 1 unit. However, if you used this postfix increment, a in this time it's going to be 3, and this is the actual value that you are going to get here, 3. However, for the next line or the next operation, it will be incremented to 3, to 4, sorry. So it's 3, you finish this operation, and now it's going to be turned into 4. However, here it's already 4 because it increments this value first. So that's the difference. At this time, this one is 4 and this one is still 3, but it's going to be changed at the end of the operation to the next increment of 4. So let's start here. So let's print the value of a, which is the 10, and let's increment it here. Yeah, let's do it this way. Let's run it. So we have to printf in one line and then the next line. Let's see the first line. What does this print? So it starts with the value of 10. So let's see what we get here. So it's 10. It prints the value of a, which is 10. So it has not changed in this first printf. However, once it is printed here, it's going to be incremented by 1 unit. So it's going to become 11, but not showing because it first shows the first value. Then incremented to 11, and if I call printf again and say, okay, print the value of a, this value has changed to be incremented by 1, so it's now 11. However, if I do the prefix operation, have a look at what happens here. Let's click save and run again. So what we do expect here, it's going to be incremented. It's 10, but we are calling this as prefix, so we are going to increment it first before printing it. So have a look here, it's already 11 because we asked this to be incremented first prior to be printed, and then printf, which is the same value because it was incremented to 11, and then we say, okay, print a again, which is 11. So bear that in mind. However, remember that it is read one line at a time and continuously executing the program. So if we do this next operation, we will have the result that we expected, a increment in postfix. But bear in mind that we have the value of a, then it's going to be incremented, so now it's 11, and if we print it here, now it's going to be let's run it, 11. As you can see, it's already 11. Why? Because we did this operation of incrementing first before calling printf. However, if we do call these two operations at the same time, that is incrementing and printing, we will have that result that I was telling you. It will read first the former value of a, and then it's going to be incremented for the next operation will be available as the increment. But in this very operation will be the former value. At the end of this operation, it will actually be incremented. So the same goes for decrement operations. So let's say b minus minus. We're going to have this result. You know how it is. It takes the former value, which is 30, b, and then it is decremented. However, I'm printing here the value of a, so let's print the value of b to see the whole process in the next slide. Okay, b minus minus, so it is the former value first, b, then it is decremented to 29, and then I call printf b, which is now 29. Okay, bear that in mind. It depends if you use these two instructions or operations at the same time, you will write first the former value. However, you can specify prefix to be decremented or incremented prior to be used, or you can use the instruction here prior to calling your instruction printf that will use uh, the value of b. So you have to decrement it first here if you want, or whatever. Use the prefix here. Bear that in mind, okay? Okay, this next topic are assignment operators. An assignment operator is when you load a value in one data, in one variable. So for instance, this one is the equal operator. What we are doing here is that we're going to store this value of this data of this datum called b in the datum called a. Okay, so we're passing this value from b to a. What does that mean? Actually the same, just as I was explaining you. However, sometimes before the equal sign you are going to find different operators which actually implied the following operation. If you say a plus equal b, what you are actually doing is that you are adding a to b and are storing the result back in a. Okay, so that a plus equal b means that you are going to add a with b and are going to store the value back in a. So it's kind of you may say saving some symbols. You are not repeating this first operand because you are performing this operation a plus b but are storing the result in the first operator. That's why you don't repeat this first operator here, but actually kind of erase it and place this plus sign here in the other side of the equal sign. So it will do the same. It is a um, subtraction assignment. So a minus equal b means that you are subtracting b from a and are storing the result back in a. Okay, so here that is the complete sentence. However, in programming languages you always use somehow cryptic or shorter expressions, so bear in mind that is the actual meaning of this. This will be the same. Multiplication and equal sign will be that you are multiplying a by b and storing the result back in a. Okay, have a look here. The same for the other operators. A divided by b and storing back in a, just like in here. A divided by b and store the result in a. So this equal means storing the result back here, and depending of the operator that you have before the equal sign, it's the operation that you're performing with this letter and the other operand, which is after the equal sign. Same here, have a look. Okay, now let's work with these assignment operators. Remember, just as I was telling you, they have this is like a simplified form uh, of noting these operations. So, for instance, as I was telling you, this equal sign means that you are transferring the contents of this data, of this datum, to this other one in the left side of the equal. However, as you can see, uh, we are doing a simplified form of A, say for instance A plus B, and will be loaded the result in the operand A. So I do A plus B and store the result back in A. However, I'm not repeating the operand A, but actually the following. I'm um, I'm deleting this A. I'm passing this operation here to express the same meaning. I am um, adding A with B and place the result back in the A datum. Okay, so remember that thing. Let's go ahead and use A, B. Okay, let's print the results here as a practice. So let's say A plus equal B. Control S, and then what we do expect 55, which is this the addition. See here, that's the result we get. And now let's say which number is bigger, B. So let's say B minus A. Remember that we changed the order. What do we have as result? So B minus A would be 35. Okay. However, if I did the in this way, we'll have the same A. Oh, sorry. B minus A. Let's store the result back in B. Let's run again, and it's the same. However, you have to be familiar with this notation, okay? Don't forget that. Now let's use, for instance, A multiplied by B. This asks for 150. Our result okay, so it's mostly the same. However, you will find this notation very often in C language, so you better get familiar with these assignments, okay? So let's do the last one, a last one. So let's say, for instance, B, we want to find the remainder of B divided by A in this notation of assignment. Let's run it, and it says 5. Yeah, remember that. It's like 45 divided by 10, but not taking fractional parts. It's like you have 40 divided by 10, and the result is 4. However, the remainder is this 5 units. The remainder that we have here, 5. Okay, bear in mind that it's really easy, but just get familiar with this notation of assignment. Relational operators are pretty much straightforward. We have seen many times in basic math terms like equal to, greater than, less than, not equal, greater than or equal to, or less than or equal to. So we basically use these relational operators to do comparisons between two numbers or two expressions in C. So have a look at this one. It says 2 is equal to 2. In C language, we use a double equal sign to mean equal to. In other cases, when we only use the equal sign just once, it's because we are loading one value into another data. However, here we are not loading any value, but actually we are comparing the two values of two different data. So remember, equal is two equal sign when we are doing comparisons. Um, so have a look here. 2 is equal to 2, and it's a true statement, so it will be evaluated as 1. There are two possible values for a statement. For instance, it may be either true or false. When it's true, it's represented with a numeric value of 1, and when it's false, it will be represented with a value of 0. So let's see the next expression. 8 is greater than 2. Yeah, it is true. So it will be evaluated to 1. Now the next expression. 7 is less than 2. Um, it's actually false. So the value given to this statement will be 0 because it is a false statement. And so on and so forth. Now let's consider this sign. It has the exclamation mark plus the equal sign, and it actually means not equal to. So let's have an example here. 9 not equal to 2. So what happens here? It's a true statement, so it will be given the value of 1 to signal that it is a true statement. Now, greater than or equal are really easy. So let's have these two examples here. 7 is greater than or equal than 4. So it is a true statement evaluated to number 1, and in this other one, which is 9, to be less than or equal to 5, it's a false statement, so it is evaluated to the value of 0, which means false. Okay, now let's bear in mind that true is given the value of 1 in C language, and false is given the value of 0. Whenever it is interpreted, a statement is interpreted as true or false. So let's use this property, which replaces this status of a statement by a numeric value, 1 or 0. So let's create first an integer variable. Let's give it a name, for instance, yell, and let's give it a the value resulting value of a expression. So let's say write, for instance, 6 equal to 0 semicolon, and let's print it here. The format specifier, comma, and the number of the variable. Let's click run. And here's the first mistake. As I was telling you, here this equal sign, which is actually doing is to load the value of this load this value in this another value. However, it's really weird. So what I'm trying to say here is 6 equal to 0? So since I am comparing, I must use this syntaxes. Double equal sign. So now I'm doing, is 6 equal to 0? It will be either 0 or 1, and will be loaded into this, will be stored in this datum called yell, and be printed here. So now it's correct here. So let's click run. And now remember, 6 is not equal to 0, so this is why yell was given the value of 0. Okay. Now the other relational operators, let's say for instance 8 is smaller or equal to let's say 18. So now this is a true statement because 8 is less or equal, any of them is actually less than 18. So it was given the value of 1 because it is a true statement, right? So bear that in mind. And now let's do another one, which is not equal. So let's say 8 is not equal to 8, which is a false statement because 8 is equal to 8. So it will be given the value of 0. And now let's see, it's not equal to 10. Now it is a true statement because both numbers are different. So since it is a true statement, it was given the value of 1.